Hello, people. Welcome to Roots of Unity. This is Mrinmoyee, and today we will be starting the topic proof by induction. Before we go into the actual induction, let us start by talking about something that we already know. This is the series of the odd numbers 1, 3, 5, 7, and so on, till the nth term that can be denoted by 2n minus 1, where n is any positive integer starting from 1. So, what happens when we try to summarize this series? This is the sigma notation which shows that we are summarizing the series of 2r minus 1 from where r is 1 and then r is 2, 3 till we reach the term where r is the nth integer. Now, let me claim something here. My hypothesis is that this summation will lead to n square. As math enthusiasts, we won't just buy into such a claim without checking whether it's true, will we? So let's check this by using some facts that we already know to be true. We know that the odd number series is an arithmetic progression with the starting value as 1 and the difference between each consecutive term 2. From O-level, we also know that the sum of the arithmetic progression can be found using this formula. So, using these facts, we can deduce another fact that the summation is indeed n squared. Wonderful. So now that we have established that this relationship is true, let us see if there's another way to prove this hypothesis. A way that requires logic and is way more interesting. In this previous example of the deductive method, we used existing facts to derive other facts. We deduced new information from the given information that this was an arithmetic sequence and the formula of the summation of the arithmetic sequence. In the method of induction, we would find trends and patterns rather than deducing new facts. We would use assumptions and generalize those to the entire series to check whether our hypothesis is true. So let's look at our hypothesis again. For all positive integer n greater than or equals to 1, we have this general statement here. We know n equals to 1 is our initial value as n is any positive integer. So let's check whether the statement is valid for the first term, which is also known as the base case. So for n equals to 1, the left-hand side of the h1 is 1. On the right-hand side, we have 1 square equals to 1, and therefore, as left-hand side is equals to right-hand side, we can say that the statement is true when h equals to 1. So the hypothesis stands for the base case. For n equals to k, we have the summation on the left-hand side. So if our hypothesis is true, if assume that it's true, the right-hand side should be k square. Now, let's keep in mind that till this point we haven't yet proven the hypothesis for n equals to k, but have just assumed that it is true. So for now, we will move on to the k plus 1th term based on the assumption that the hypothesis was true for the summation till kth term. So for the left-hand side, this summation till the k plus 1th term can be rewritten as a summation till the kth term plus the individual k plus 1th term itself. We can simplify this and then get k square plus 2k plus 1, which we know is equals to k plus 1 whole square. As our n was k plus 1, this k plus 1 whole square shows that we have reached n square, that is, the left-hand side is equals to the right-hand side for n equals to k plus 1. So the hypothesis for k plus 1 stands based on the assumption that it was true for n equals to k. So where do we stand now? We know that the hypothesis is true for the base case, that is the initial value of n. Then we are assuming that hk is true, based on which we proved that if hk is true, we can use that value to prove hk is true too. Now that we can start to think about the actual induction. Though some of us might not have realized it yet, but we have actually done all the hard work of proving the hypothesis already. How so? With this three key information, we can start to think the series of terms as a series of dominoes. So we know that for the base case n equals to 1, the hypothesis is true. Now, if we think that k was 1, remember we assumed that the hypothesis was true for k. So let's think that k was 1. And using that knowledge that if k term is true, then the next term is true too, we can start to generalize. So if the term is true, the second term would be true too. If the hypothesis is true for n equals to k equals to 2, then it will be true for n equals to k plus 1, that is n equals to 3 too. Then this pattern will continue, where each term being true will lead to the next term being true. So the hypothesis is true for any n where n is greater than or equals to 1. Therefore, since the hypothesis is true for the base case, and we know that assuming it as true for any k term leads to it being true for the next term, that is the k plus 1th term, by the virtue of mathematical induction, the hypothesis stands and is true for all n greater than or equals to 1. And this is proof by induction. If you have any further question related to proof by induction, please reach out to us through the comment section or inbox us your queries. Thank you so much for watching the video. Stay happy, stay healthy, and stay with Roots of Unity. Thank you so much.